press the bell icon on the YouTube app and never miss another update.
Hello students, welcome back to the video classes. Today let us move on to the purification, methods of purification of organic compounds. See here we have 5 important methods of purification of organic compounds: sublimation, crystallization, distillation, differential extraction and chromatography. So, depending on the nature of impurity associated with the organic compound, so we can go for the different methods of purification of organic compounds: sublimation, crystallization, distillation, differential extraction and chromatography. So, before going to these methods, let us consider what do you mean by purification of organic compound. Purification is nothing but the process of removal of undesirable means which is not required, undesirable impurities associated with the organic compound is called purification. I will repeat, the process of removal of undesirable impurities associated with the organic compound is called purification. On the basis of nature of organic compound and impurities present along with that, so we can apply any of the methods here, either sublimation, crystallization, distillation or differential extraction or the chromatography. Okay. So, let us go with one by one here. So, first one, what do you mean by sublimation? Sublimation. So, you know what do you mean by sublimation, you know what do you mean by boiling, melting, and in the same time what do you mean by sublimation. So, it is a process where the substance is get directly converted to vapor state without undergoing the liquid state. So, the process where the substance directly the solid substance directly get converted to the vapor state without undergoing the liquid state, without melting. If any solid substance gets converted to vapor state, then it is called sublimation. So, let me give the examples here: iodine, benzoic acid C6H5COOH, naphthalene, anthracene and camphor. So, these are compounds are called volatile solids. Volatile solids. Why they are called volatile solids? On heating, these solid compounds are directly gets converted to the vapor state. Therefore, these are all called volatile solids when they are associated with non-volatile solids. Volatile means which are having or which can directly or which easily vaporizes. Any compound if easily vaporizes means then it is called volatile. Okay. So, the process of separation of volatile solids from non-volatile impurities on the basis of the volatile solid pass into vapor state without melting, and that process is called sublimation. The process of separation of volatile solids from non-volatile impurities on the basis of tendency of these solids to pass into vapor state without melting, and that process is called sublimation. So, when iodine or the benzoic acid or the camphor, when it is heated, when it is associated with an impurity, on heating this iodine or the naphthalene or the camphor, these compounds directly get converted into vapor state, leaving behind impurities. Then we can say these solids are volatile solids. Once it forms an vapors, then it leaving behind the impurities means that vapors that can be condensed again back to the solid, and where will get the pure solid, and that process is called sublimation. The process of separation of non-volatile solids means volatile solids which can easily converted into vapor state without melting. So then they are called, then the process is called sublimation. The process is called sublimation. Iodine, benzoic acid, naphthalene, anthracene, camphor can be purified by this sublimation method because these solids are volatile solids. So these solids directly get passed into vapor state without melting, ಅಂದ್ರೆ ಲಿಕ್ವಿಡ್ ಸ್ಟೇಟಿಗೆ ಹೋಗಲ್ಲ. ಸೊ ಫಸ್ಟ್ ಪ್ರಾಸೆಸ್ ಆ್ಯಕ್ಚುಲಿ ನಾರ್ಮಲ್ ಪ್ರಾಸೆಸ್ ಏನಿರುತ್ತೆ, ಸಾಲಿಡಿಂದ ಲಿಕ್ವಿಡ್ಗೆ, ಲಿಕ್ವಿಡಿಂದ ಗೇಷಿಯಸ್ ಸ್ಟೇಟ್ ಅಥವಾ ವೇಪರ್ ಸ್ಟೇಟಿಗೆ ಹೋಗೋದಿರುತ್ತೆ. ಬಟ್ ದೀಸ್ solids are directly converted to vapor state without melting. So therefore these compounds can be purified by sublimation. Clear? Now let us move on to the second one. Second method is nothing but, second one is nothing but crystallization. Crystallization. So what do you mean by crystallization? So it is the process where the precipitation of pure solid, pure organic compound from its saturated, that is super saturated solution. Super saturated solution. So this is a super saturated solution of a compound from which we need to precipitate the required organic compound. So the precipitation of pure organic compound from the supersaturated solution, from its supersaturated solution, either by cooling, when supersaturated solution, either by cooling or allowing the supersaturated solution for a longer time. So by longer time, by adding one or two crystals of the organic compound. So then the crystallization of the compound takes place that can be separated by filtration. So this process is called crystallization. The process, the precipitation of the pure organic compound from its supersaturated solution, either by cooling or by standing this solution for a longer time. So then it is called the crystallization process. The principle behind this crystallization process is differential solubility of the components in a same solvent. So when the solvent ಅಲ್ಲಿ 2 or more components in a solubility, rate of solubility differ ಆಯಿತು ಅಂತಂದರೆ, then we can go for crystallization. For example, the pure organic compound which is to be crystallized is more soluble. So the compound which is more soluble precipitates very easily. ಯಾವ ಕಾಂಪೌಂಡು ಈಸಿಯಾಗಿ ಸಾಲ್ಯುಬಲ್ ಆಗುತ್ತೋ ಅದು ಈಸಿಯಾಗಿ ಪ್ರಿಸಿಪಿಟೇಟ್ ಆಗುತ್ತೆ. ಯಾವ ಸಾಲ್ಯುಬಲ್ಲು ಜಾಸ್ತಿ ಸಾಲ್ಯುಬಲ್ ಆಗುತ್ತೋ ಸಾಲ್ವೆಂಟಲ್ಲಿ ಅದು ಸ್ಲೋ ಆಗಿ ಏನಾಗುತ್ತೆ, ಪ್ರಿಸಿಪಿಟೇಷನ್ ಆಗುತ್ತೆ. ಸೊ ಮೋರ್ ದ ಸಾಲ್ಯುಬಿಲಿಟಿ, ಮೋರ್ ಈಸ್ ದ ಪ್ರಿಸಿಪಿಟೇಷನ್ ಆಫ್ ದಟ್ ಕಾಂಪೌಂಡ್ ಫ್ರಮ್ ದ ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್. So let me give, what do you mean by super saturated solution? See here, take a beaker and take some water here, take some water and add a solute, and you know that it is a solvent, correct? When solute dissolves in a solvent, you can say it gives a solution, correct? Now, so let me take the same amount of solvent here. Here I have added 1 gram of solute. And here to this beaker, just I am go on adding the solute here. So go on adding the solute, it dissolves in a given amount of solvent such that, so after some time, some solute particles are left at the bottom of the beaker. Some solute particles are left at the bottom of the beaker. We can see some solute particles at the bottom of the beaker. Then you can say this solution is called saturated solution. So it means to say, ನಾವು ಸಲ್ಯೂಟನ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ ಗಿವನ್ ಅಮೌಂಟ್ ಆಫ್ ಸಾಲ್ವೆಂಟಲ್ಲಿ. ಈಗ 10 ml ಆಫ್ ವಾಟರಲ್ಲಿ ಶುಗರ್ನ ಆ್ಯಡ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. ಅಟ್ ಒನ್ ಪರ್ಟಿಕ್ಯುಲರ್ ಟೈಮಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಶುಗರ್ ಪಾರ್ಟಿಕಲ್ಸ್, ಶುಗರ್ ಕ್ರಿಸ್ಟಲ್ಸ್ ನಮಗೆ ಬೀಕರಲ್ಲಿ ಕಾಣಿಸುತ್ತೆ. then that indicates that the solution is saturated solution. Saturated means the solvent dissolves excess of solute than it can dissolve. ಅದು ಡಿಸಾಲ್ವ್ ಎಷ್ಟು ಮಾಡ್ಕೊಳ್ಬೇಕು ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡಿರುತ್ತೆ. ಹಾಗಾಗಿ ದ ರೇಟ್ ಆಫ್ ಪ್ರಿಸಿಪಿಟೇಷನ್ ಆ್ಯಂಡ್ ರೇಟ್ ಆಫ್ ಸಾಲ್ಯುಬಿಲಿಟಿ ಏನಾಗಿರುತ್ತೆ ಇಲ್ಲಿ ಸೇಮ್ ಆಗಿರುತ್ತೆ. ರೇಟ್ ಆಫ್ ಪ್ರಿಸಿಪಿಟೇಷನ್ ರೇಟ್ ಆಫ್ ಸಾಲ್ಯುಬಿಲಿಟಿ ಸೇಮ್ ಆದಾಗ ದ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ನಾವು ಆ ಕ್ರಿಸ್ಟಲ್ಸ್ ಅನ್ನ ಏನು ಮಾಡ್ಬೋದು, ವಿ ಕ್ಯಾನ್ ಸಿ ದ ಕ್ರಿಸ್ಟಲ್ಸ್, few crystals of solute at the bottom of the beaker, then this solution is called saturated solution. What is this solution called? Saturated solution. Okay, saturated solution. Now what do you mean by super saturated solution? Now you take the same amount of solvent here, same amount of solvent na tagoli, same amount of solvent into which you add solute. Just you heat this solvent and then you add solute. So ಸ್ವಲ್ಪ solvent na heat ಮಾಡಿ ಆಮೇಲೆ solute add ಮಾಡಿ, then this solvent dissolves more the solute than in saturated solution. For example, saturated solution ಅಲ್ಲಿ 50 grams ಶುಗರ್ನ ಡಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡಿರತ್ತೆ. ಇಲ್ಲಿ 1 ಗ್ರಾಮ್ ಆಫ್ ಶುಗರು ಡಿಸಾಲ್ವ್ ಆದರೆ ನಾವು, ಅಥವಾ 1 or 2 grams ಆಫ್ ಶುಗರ್ ಡಿಸಾಲ್ವ್ ಆದರೆ ಅದನ್ನು ಸೊಲ್ಯೂಷನ್ ಅಂತ ಕರಿತೀವಿ. ಸಲ್ಯೂಟ್ ಡಿಸಾಲ್ವ್ ಇನ್ ಎ ಸಾಲ್ವೆಂಟ್ ಆ್ಯಂಡ್ ಗಿವ್ಸ್ ಎ ಹೋಮೋಜಿನಿಯಸ್ ಮಿಕ್ಸ್ಚರ್. ಬಟ್ ಇಲ್ಲಿ 50 grams ಆಫ್ ಶುಗರ್ನ ಆ್ಯಡ್ ಮಾಡಿದ್ದೀವಿ, ದೆನ್ ಇಟ್ ರೀಚಸ್ ಎ ಪಾಯಿಂಟ್ ಕಾಲ್ಡ್ ಸ್ಯಾಚುರೇಷನ್ ಪಾಯಿಂಟ್ ಆ್ಯಂಡ್ ದ ರಿಸಲ್ಟಿಂಗ್ ಸೊಲ್ಯೂಷನ್ ಇಸ್ ಕಾಲ್ಡ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್. ಈಗೇನು ಮಾಡಿದ್ದೀವಿ, ಸೊ ಜಸ್ಟ್ ವಾರ್ಮ್ ಮಾಡಿ ಹೀಟ್ ಮಾಡಿದ್ದೀವಿ ಸಾಲ್ವೆಂಟ್. ನೌ ವಿ ಆರ್ ಆ್ಯಡಿಂಗ್ solute. So then definitely it dissolves more than 50 grams of sugar. ಇಲ್ಲಿ more than 50 grams of sugar na ಅದು dissolve ಮಾಡ್ಕೊಳ್ಳುತ್ತೆ. Then the resulting solution is called super saturated. ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್. ಏನು ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್? ಸೊ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಅಲ್ಲಿ ಎಷ್ಟು ಶುಗರ್ನ ಡಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಳ್ಬೇಕಿತ್ತು? 50 grams. So 50 grams of sugar dissolved in saturated solution, but in this solution it is more than 50 grams. The amount of solute dissolved more than in the saturated solution. Saturated solution ಅಲ್ಲಿ ಎಷ್ಟು ಡಿಸಾಲ್ವ್ ಆಗಿದೆಯೋ ಅದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಡಿಸಾಲ್ವ್ ಮಾಡ್ಕೊಂಡಿರತ್ತೆ ಇಲ್ಲಿ. Then the resulting solution is called super saturated solution. To this super saturated solution, if we add a crystals of the compound, ಅದೇ ಶುಗರ್ನ ಕ್ರಿಸ್ಟಲ್ಸ್ ಹಾಕಿದಾಗ, ಸೊ ಹಿಯರ್ ಇಟ್ ಫಾರ್ಮ್ಸ್ ಎ ಶುಗರ್. ಸೊ ಅದೇ ಶುಗರ್ ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನಿಗೆ 2 or more ಕ್ರಿಸ್ಟಲ್ಸ್ನ ಹಾಕಿದಾಗ ದೆನ್ ವಿ ಕ್ಯಾನ್ ಕಾಲ್ ಇಟ್ ಆಸ್ ಸೀಡಿಂಗ್ ಪ್ರಾಸೆಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಬೈ ಸೀಡಿಂಗ್ ಪ್ರಾಸೆಸ್, ಸೊ ಬೈ ದಿಸ್ ವೇ ವಿ ಕ್ಯಾನ್ ಪ್ರೆಸಿಪಿಟೇಟ್ ದ ಆರ್ಗ್ಯಾನಿಕ್ ಕಂಪೌಂಡ್ ಫ್ರಮ್ ಇಟ್ ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಐದರ್ ಬೈ ಕೂಲಿಂಗ್. ಸೂಪರ್ ಸ್ಯಾಚುರೇಟೆಡ್ ಸೊಲ್ಯೂಷನ್ ಪ್ರಿಪೇರ್ ಆದಮೇಲೆ ಐದರ್ ಬೈ ಕೂಲಿಂಗ್ ಆರ್ ಬೈ standing or by allowing the supersaturated solution to stand for a longer time by adding 2 or more crystals or by seeding process, then the crystals of that compound takes place. So and that process is called crystallization. So best we can use this process for copper sulfate solution. We can go for sodium acetate solution. Sodium acetate ಗೆ ಬಹಳಷ್ಟು ಯೂಸ್ ಮಾಡ್ತೀವಿ. Benzoic acid can be crystallized, purified by crystallization. Copper sulfate can be purified by crystallization. So for that, first we need to prepare super saturated solution of copper sulfate. Super saturated solution of copper sulfate na ನಾವು ಪ್ರಿಪೇರ್ ಮಾಡ್ಕೊಳ್ಬೇಕು. Just by heating the water, we need to dissolve excess of copper sulfate in a given amount of a solvent. Then this super saturated solution of copper sulfate is allowed to stand for long time by adding few crystals of copper sulfate. Super saturated solution prepare ಆದಮೇಲೆ ಅದಕ್ಕೆ few crystals of copper sulfate ನ ಹಾಕಿದಾಗ ಆ process ನ ಏನು ಕರಿತೀವಿ? Seeding. So when we add few crystals of copper sulfate, so it produces crystals. ಇಲ್ಲೇ crystals ಏನಾಗುತ್ತೆ? Formation ಆಗುತ್ತೆ. The formation of crystal takes place around this crystal, added crystal. So ಅಲ್ಲಿ produce ಆಗುತ್ತೆ crystals. So that process is called crystallization. That process is called crystallization. Whenever there is a difference in the solubility, differential solubility of a components present in a mixture in a same solvent, then we can apply crystallization. It is nothing but the process of precipitation of the pure compound from its supersaturated solution either by cooling or by allowing the solution for a longer time. Okay, now let us move on to the third method. Third one. So third process is nothing but distillation. Third process, distillation. So distillation method is a very simple method. This is mainly based on the boiling point of the liquids present in a mixture. So distillation is mainly based on the boiling point of liquids present in a mixture. On the basis of nature of the liquids present in a mixture, we can classify distillation into four types. What are those? Simple distillation, simple distillation. Second one, fractional distillation, fractional distillation. Third one, steam distillation, steam distillation. Fourth one, distillation, distillation under reduced pressure, under reduced pressure. So these are the four methods of distillation: simple distillation, fractional distillation, steam distillation, distillation under reduced pressure. So in the process of separation or the purification of organic compound, so this is one of the common methods for the separation or the purification of liquid mixtures, so which are differ in boiling point. The very basic principle behind distillation is boiling point of components present in a mixture. So this is the apparatus setup for the simple distillation. Just by changing few things here, we can go with the four methods of distillation with the same apparatus. Okay, so this is, you know that this is a round bottom flask which is fitted with a thermometer here to note down the temperature of the liquid mixture, and this is the delivery tube, and this tube is connected to condenser. So this is called water condenser. Water condenser means cold water is circulating inside. This is water in and this is water out. So in one side the water inlet and on other side we have water outlet, and this is water condenser. Water condenser, it condenses the vapors to the liquid. When the vapors are liberated from the round bottom flask, it is passed through this condenser. Because of circulating the cold water, it get condensed to liquid and which is collected in this conical flask, and it is distillate. So distillate which is collected after distillation. So this is the setup apparatus which is required for the process of distillation. Okay, the simple apparatus that we can use: round bottom flask and water cooled condenser, and also the conical flask to collect the distillate. Okay, now what do you mean by simple distillation? So in case of simple distillation, so whenever there is a difference in the boiling point, much difference in the boiling point, so much difference in boiling point, then we can easily separate the liquids, mixture containing the liquids. So here, whenever this process is applicable for the separation of individual liquids from the liquid mixture where the liquids are having much difference in the boiling point. So and even this simple distillation can be used to separate two liquids which are much differ in their boiling point. So this is the simple method we can use to separate two liquids which are much differ in their boiling point. So let me take the example here. Example, you can take chloroform, mixture of chloroform and aniline. You can take the mixture of chloroform and aniline. Second mixture you can take hexane, N-hexane and toluene. So what is the boiling point of chloroform? 334 Kelvin, and that of aniline is 457 Kelvin, and hexane is 342 Kelvin, and that of toluene is 385 Kelvin. So there is a much difference in the boiling point of chloroform and aniline, and much difference in the boiling point of hexane and the toluene. So these mixtures can be separated by using simple distillation. Let us take a mixture containing chloroform and aniline in a round bottom flask. On heating the mixture, what happens? The liquid with a low boiling point vaporizes first, and it passes through the condenser, and then it is condensed to liquid back, and which is collected in a conical flask. In that way we can separate chloroform from that of the aniline. ಇಲ್ಲಿ chloroform ಮತ್ತು aniline mixture ನ ತಗೊಂಡ್ರೆ first vaporize ಆಗೋದು ಯಾವುದು? Chloroform, because which is having lower boiling point. The liquid with low boiling point vaporizes first, and the vapors of chloroform get passed through the condenser, and it get condensed to liquid, and which is collected in a conical flask, and here leaving behind aniline. So in that way we can go with the simple distillation. The process of simple distillation is to separate the individual liquids from the liquid mixtures which are much differ in the boiling point. That is the principle behind the simple distillation, and even this method is also used to separate the two liquids, mixture of two liquids, and we can separate the impurities, high boiling impurities present along with the low boiling organic compound. So that is about the simple distillation. Okay, now let us move on to the second one called fractional distillation. Fractional distillation. So if we have a liquid mixture, so liquid mixture means which are having two or more liquids and which are not much difference in the boiling point. So consider a liquid mixture in which the liquids are having less difference in their boiling point. Whenever the difference of boiling point is very less, then we can go with the fractional distillation. So in the fractional distillation, this conical flask must be fitted with fractionation tower. It must be fitted with fractionation column. So this is fractionating column, and this column is packed with glass beads. Okay, and this is called fractionating column. So this fractionating column is fitted in this round bottom flask. We need to set up the fractionating column to this round bottom flask, and this is the fractionating column which is packed with glass beads. Now you need to take the liquid mixture here. So you need to take the liquid mixture here. So this should be, it should be connected to the round bottom flask, and we need to take the liquid mixture here, which are less difference in their boiling point. So now on heating this mixture, so what happens? Vapors of the mixture forms. So it forms a vapors of this liquid mixture, and the vapors of the mixture is allowed to pass through the fractionating column. So the vapors of liquid mixture is allowed to pass through the fractionating column, so that the vapors of liquid with high boiling point condenses first, and then the vapors of liquid with low boiling point rises up, or it passes through the fractionation tower. So ಯಾವ ಲಿಕ್ವಿಡಿನ ಬಾಯ್ಲಿಂಗ್ ಪಾಯಿಂಟ್ ಹೈ ಇರುತ್ತೆ, so then that condenses near the bottom of the fractionating column, but the liquid with low boiling point, the vapors of the liquid with low boiling point rises up, or it is passed through this fractionating ಕಾಲಮ್. ಅಂದರೆ ಆ ವೇಪರ್ಸ್ ರೈಸ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಯಾವ ವೇಪರ್ಸ್ ರೈಸ್ ಆಗ್ತಿರತ್ತೆ? ಸೊ ದ ವೇಪರ್ಸ್ ರೈಸಿಂಗ್ ಇನ್ ಎ fractionating column, but some vapors are get condensed at the bottom of the fractionating column. So ಎಲ್ಲಿ bottom of the fractionating column ಅಲ್ಲಿ condense ಆಗುತ್ತೆ ಅಂದರೆ what it indicates? It indicates that that liquid is having very high boiling point, because in fractionating column the temperature is increased from top to bottom. So high boiling, the vapors of high boiling liquid condenses, whereas the vapors of liquid with low boiling point rises in the fractionating tower. Okay, now why the fractionating column is packed with glass beads? So illi condense aagta irutte, vapors are get condensed to liquid, and the liquid is descending in a fractionating column, whereas vapors are ascending in a fractionating column. When the glass beads are there, the interaction between the descending condensed liquid and ascending vapors are more. When the interaction between these two is more, the separation is easier. The more effective is the separation. Fractional distillation effective ಆಗಕ್ಕೆ ಗ್ಲಾಸ್ ಬೀಡ್ಸನ್ನ ಪ್ಯಾಕ್ ಮಾಡಿರ್ತಾರೆ. ಸೊ ಇನ್ಸ್ಟೆಡ್, ಈಗ ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಒಂದು ಗುಡ್ಡ ಹತ್ತಬೇಕು ಅಂದರೆ ಹಾಗೆ ಹತ್ತೋಗಿಂತ ಸ್ಟೆಪ್ಸ್ ಇತ್ತು ಅಂದರೆ ಏನಾಗ್ತದೆ, ಈಸಿಯಾಗಿ ಹತ್ತಕ್ಕಾಗತ್ತೆ. ಹಾಗೆಯೇ ಸೊ ದ ಅಸೆಂಡಿಂಗ್ ವೇಪರ್ಸ್ ಆ್ಯಂಡ್ ದ ಡಿಸೆಂಡಿಂಗ್ condensed liquid, they interact in this fractionating column. So to make this interaction more effective, the glass beads are packed inside the fractionating column. More the effective interaction between the descending liquid and the ascending vapor, more is the effective separation. So therefore the fractionating column is packed with glass beads. So slow ಆಗಿ liquid, condensed liquid ಏನಾಗುತ್ತೆ, descend ಆಗುತ್ತೆ, whereas vapors are ascending in a fractionating column. So this is the principle behind the fractional distillation. Fractional distillation means the separation of liquid mixture into useful fractions on the basis of their boiling point, where the liquids are having less difference in their boiling point. The process of separation of liquid mixture into useful fractions depending on their boiling point in a fractionating column, and that process is called fractional distillation. You heard about this fractional distillation for petroleum, correct? So you studied the petroleum, fractional distillation of crude oil or the petroleum oil. So where we have to subject this petroleum to the fractional distillation, because we have kerosene, lubricating oil, and petrol and gasoline. All these are present in crude oil. So we need to separate them into useful fractions by subjecting it to fractional distillation. The boiling point of kerosene and boiling point of petrol are not much difference. So therefore the fractional distillation of crude oil can separate the kerosene, lubricating oil, and the petrol and the gasoline. When the same petroleum oil or the crude oil is taken here in the round bottom flask, On heating it forms a vapors. Once the vapors rises, first which component distillates here? Lubricating oil, because which having a higher boiling point, then the kerosene, then the petrol, then the gasoline, because depending on the boiling point it gets separated into useful fractions, and the process is called fractional distillation. And additional apparatus here, the round bottom flask must be fitted with the fractionating column. Okay, now let us move on to the next one called steam distillation. So we can use fractional distillation for the separation of useful fractions of not only the petroleum, we can also go with the coal tar. Coal tar distillation can be done again by fractional distillation. Coal tar containing benzene and toluene. So since it containing benzene and toluene, so we need to separate benzene from that of the toluene again by fractional distillation. The reason for that is there is a much less difference in the boiling point of benzene and toluene, therefore we need to go for fractional distillation. Similarly, when ethanol is associated with water, so when ethanol is associated with water, so for example if we take 10% ethanol, 10% means so around 10 parts of ethanol is associated with 90 parts of ethanol. In order to purify that ethanol, 10% ethanol irutte C2H5OH, remaining 90% water irutte. So to separate water from that of the ethanol, to purify this again we need to go for fractional distillation. After fractional distillation we will get 95.5% ethanol. 95.5% ethanol means complete reverse. 95.5 parts of ethanol and only 4.5% of water ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ ಉಳ್ಕೊಳ್ಳುತ್ತೆ. ಅಂದರೆ ಅಷ್ಟು ವಾಟರ್ನ ಅದೇನು ಮಾಡುತ್ತೆ, ಡಿಸ್ಟಿಲೇಟ್ ಮಾಡುತ್ತೆ, ಸೆಪರೇಟ್ ಮಾಡುತ್ತೆ. ಸೊ even we can go for the purification of ethanol which containing only 10%, that can also be done by fractional distillation. Clear? Now let us move on to the next one, the third one called steam distillation. So this distillation process is applied for that liquid which is volatile, steam volatile. What do you mean by steam volatile? What do you mean by steam volatile? Just by passing steam, if a liquid vaporizes, then it is called steam volatile. So this is the method which is used to purify the steam volatile organic compound, and that steam volatile compound must be immiscible with water. It should not be soluble in water. It is insoluble in water. Steam volatile ಆಗಿರಬೇಕು, insoluble in water ಆಗಿದ್ರೆ we can easily purify that compound by steam distillation. This is the process of purification of steam volatile liquid and which is immiscible with water. Best example is aniline. Aniline, aqueous solution of aniline. What do you mean by aqueous solution of aniline? Aniline is associated with water, but aniline is immiscible with water, and aniline is a steam volatile, means by passing steam through this aniline, it vaporizes very easily. Not only aniline, we can give few more examples here. So steam distillation can be done with orthonitrophenol, O-nitrophenol, and nitrobenzene. Nitrobenzene can also be separated by steam distillation. Aniline is also purified by steam distillation. Aniline and bromobenzene. One more is bromobenzene. One more is bromobenzene. One more is bromobenzene. Okay, so all these compounds are volatile compounds, or steam volatile compounds, and they are immiscible with water. So these compounds can be purified by steam distillation. aniline, orthonitrophenol, nitrobenzene and bromobenzene. So these are the compounds that can be purified by steam distillation because these compounds are steam volatile, which means to say by passing steam, so they get vaporized. Now how to purify this aqueous solution of aniline? So the same setup you had to take, and here we have aniline which is associated in aqueous solution. We had to take aqueous solution of aniline in a round bottom flask, and into which we need to connect one more round bottom flask. So this is one more round bottom flask we need to connect. So one more round bottom flask in which we have to take water, and on heating it gives a steam. Okay, and this conical flask again connected with one more round bottom flask which containing water. On heating it produces steam, and this steam is passed through this round bottom flask which containing aniline in aqueous medium. Now what happens? On passing this steam, aniline vaporizes, then the vapors are passed through this condenser. So vapors are coming out of the round bottom flask. Illi vapors baratte, and what are these vapors containing? So vapors containing aniline and steam. So we need to pass steam to the round bottom flask which containing a mixture of aniline in water. When steam is passed through this, as aniline is steam volatile, it vaporizes, and the vapors are coming out of the round bottom flask, and these vapors are containing aniline and again a steam, and this is condensed in a conical flask. This is condensed in a conical flask. What is steam? It is again the water, aniline and the steam get condensed back to liquid, and it is collected in a conical flask, and it is leaving behind other impurities which are present in water. So water alli other impurities ille bittu bare aniline matra enagutte vapors agi convert agutte, and the vapors of aniline is associated with the steam, and these vapors are when passed through the water cooled condenser, it get condensed to liquid, and as we know that here it forms a separate layer. Here it forms a separate layer because aniline is immiscible with water. Since it is not soluble with water, it forms a two layers. One layer is aniline, another layer is the condensed steam. Condensed steam andre water. So here it is aniline and here it is water. These can be separated by separating funnel. So as aniline is immiscible with water, that condition is already given. Steam distillation is applicable to that liquid which is steam volatile and it is immiscible with water. The vapors obtained from the distillation flask is associated with aniline and a steam which get condensed liquid, and it is collected in a conical flask and it forms a separate layer because aniline is immiscible with water, and that can be separated by separating funnel. Okay, and this is about the steam distillation. Now let us move on to the next one called distillation under reduced pressure. So this method is used for those liquids which are having very high boiling point. So this is the method which is used for the purification of that liquid which is having very high boiling point. Okay, so for example, glycerol. So let us move on to the next one called distillation under reduced pressure. You can use glycerol, can be purified by using distillation under reduced pressure. So this method is applicable for that liquid which is having very high boiling point and it decomposes at or below its boiling point. So therefore, so let me take the example of glycerol which is having very high boiling point. This method is commonly used in soap factory. So in order to separate glycerol from the spent lay in the, now glycerol na separate madake, to separate glycerol from spent lay, so we can use spent lay, we can use this method called distillation under reduced pressure. So whenever after the manufacture of the soap, in order to separate the glycerol from that of the soap mixture, we need to apply distillation under reduced pressure, and this glycerol is having very high boiling point. To separate glycerol from spent lay, we can use this distillation under reduced pressure. Spent lay, it is the filtrate which is obtained after the manufacture of soap. Okay, to separate glycerol associated with this spent lay, we can use distillation under reduced pressure. So what happens here? The liquid to be separated is heated and below its boiling point. Then by applying pressure on the surface of the liquid, so we need to heat this mixture, that is spent lay, below the boiling point of glycerol, so that by applying the high pressure, by applying the pressure on the surface of the spent lay, we need to apply the pressure by using manometer on the surface of the spent lay, so that the glycerol distills or it decomposes below its boiling point and collects as a distillate in the conical flask, and that is the method called distillation under reduced pressure, and this is used only for the separation or the purification of high boiling liquid. Example is glycerol. So it distills below its boiling point on heating, and then it condenses to liquid in a conical flask. So the one additional thing here is we need to apply pressure on the surface of this mixture, on the surface, okay, by using manometer, and this is about the distillation under reduced pressure. Now let us move on to the next one called differential extraction. Fourth one, differential extraction. Differential extraction. So this method mainly used for the separation of organic compound, pure organic compound, from its aqueous solution. So the method is used for the separation of pure organic compound from its aqueous solution. Whenever the organic compound is associated in water, if it is slightly soluble in water, then if the compound is soluble in water, then in aqueous solution, from aqueous solution, we can easily separate the pure organic compound by using differential extraction. But it depends on the principle behind that is the separation of pure organic compound from its aqueous solution by adding another organic solvent, and that organic solvent is immiscible with water. So for example, let me take the aqueous solution of some compound, aqueous solution of some organic compound I have taken, into which we need to add one organic solvent here. So this organic solvent dissolves the organic compound, but this organic solvent is immiscible, insoluble with water. So this, in that way we can easily separate the pure organic compound. So let me give the example here. Take an aqueous solution of benzoic acid. So this is aqueous solution. Let me take it in a separating funnel. Usually this method is used or it is done in a separating funnel. So this is separating funnel. So this is separating funnel. So the separating funnel, that is commonly used apparatus. Okay, in which we need to take, this is aqueous solution of benzoic acid. Let me take benzoic acid here. So this is aqueous solution of benzoic acid. So this is aqueous solution of benzoic acid. Okay, so aqueous solution of benzoic acid. Aqueous solution of benzoic acid. Aqueous solution of benzoic acid means benzoic acid dissolved in water. Now we need to separate this benzoic acid from water. So because it is soluble in water, so it is slightly soluble in water. So here it is present in a form of solution, aqueous solution. Okay, now into which we have to add a solvent. We need to add a solvent here. Let me take benzene. Now I add, we need to add some amount of benzene into the aqueous solution of benzoic acid. So add benzene here. This is an organic solvent. Now what happens? The benzoic acid present in aqueous solution is get passed through see here. So now here, see here, benzoic acid is here in aqueous solution. After adding benzene, what happens? The benzoic acid present in the aqueous solution is passed to, it get passed to what? Benzene. So benzoic acid in water aqueous solution ಅಲ್ಲಿ ಇರುತ್ತೆ, ಅದೆಲ್ಲದು ಏನಾಗುತ್ತೆ? benzene layer ಗೆ shift ಆಗುತ್ತೆ. It get passed to the benzene layer because the benzoic acid is more soluble in benzene than in water, because it is an organic solvent and this is an organic compound, like dissolves like. Therefore the benzoic acid present in an aqueous solution is passed to the benzene layer. It get dissolves in benzene because it is more soluble in benzene than in water. Illiro benzoic acid ella ellige hogutte? Benzene layer ige hogutte. Now it forms a layer like this. All the benzoic acid is get passed to the benzene layer leaving behind water. So idana naven karitivi aqueous layer, and this is organic layer. Why it is organic layer? Because an organic compound is dissolved in organic solvent. As we know that organic compound is non-polar and it dissolves more in non-polar solvent. So like dissolves like, therefore, so benzoic acid passes from aqueous layer to organic layer because it is more soluble in benzene, and it forms a separate layer, and these can be separated by through this separating funnel. First aqueous layer na separate ಮಾಡ್ಕೊಳ್ತೀವಿ, ಆಮೇಲೆ organic layer na separate ಮಾಡ್ಕೊಳ್ತೀವಿ. Then how to separate benzoic acid from that of benzene? By again the distillation, or we can go for evaporation also, because it evaporates easily leaving behind benzoic acid. And this is about the differential extraction. The differential extraction is based on a principle that, what is the principle behind this? Difference in the solubility of a given organic compound in aqueous layer and in a organic layer. And as we know that organic compound is more soluble in organic solvent. By using that principle, we can go with the differential extraction, the separation of the pure organic compound from its aqueous layer or from its aqueous solution by adding another organic solvent, and that solvent is immiscible with water. Organic solvent ಮತ್ತೆ ವಾಟರ್ ಡಿಸಾಲ್ವ್ ಆಗೋಂಗಿಲ್ಲ, ಹಾಗಾಗಿ ನಾವು ಎಥೆನಾಲ್ ತಗೊಳ್ಳೋಗಿಲ್ಲ. ಇಲ್ಲಿ ಎಥೆನಾಲ್ ತಗೊಂಡ್ರೆ ಏನಾಗುತ್ತೆ? ಇಟ್ ಇಸ್ ಸಾಲ್ಯುಬಲ್ ಇನ್ ವಾಟರ್. ವಿ ಕೆನಾಟ್ ಟೇಕ್ ಎಥೆನಾಲ್ ಹಿಯರ್. ಯಾವ ಆರ್ಗ್ಯಾನಿಕ್ ಸಾಲ್ವೆಂಟ್ ವಾಟರಲ್ಲಿ ಡಿಸಾಲ್ವ್ ಆಗುತ್ತೆ ಅದನ್ನು ತಗೊಳ್ಳೋ ಹಾಗಿಲ್ಲ. ಸೊ ದಟ್ ಆರ್ಗ್ಯಾನಿಕ್ ಸಾಲ್ವೆಂಟ್ ವಿಚ್ ಇಸ್ immiscible with water, that we need to take. So then that is nothing but the differential extraction. And the last method is nothing but the last one, chromatography. Let us move on to the chromatography. So the last method for the purification here is chromatography. Let's move on to chromatography here. Fifth one, chromatography. So what do you mean by chromatography? So chromato means color, graphy means writing. Here we can separate. This method is used for the separation of individual components from the mixture, and those components may be colored or it may be colorless. And even we can use this method for the purification of the components, and even we can use this method to check the purity of the compound also. So let us move on to, in chromatographic technique, what is the principle behind this? So this is based on a fact that the adsorptive capacity of different individual components or differential movement of individual components, where the movement of these individual components takes place. So in this process, the a mixture to be separated, or the components to be separated, should be allowed to separate through a stationary phase. So we need to take a mixture to be separated on a stationary phase, and the mixture should be separated into individual components by using mobile phase. So the mixture to be separated into individual components, that should be done in a stationary phase by the influence of this mobile phase. What is this stationary phase? The fixed one. Mobile phase is moving one. There are two phases here. One is fixed, another one is moving. So therefore stationary phase and the mobile phase, depending on the movement of the components between these two phases, the process can be applied for the separation of individual components from a mixture, that is mainly based on movement of individual components between these two phases. One is stationary, another one is mobile. What is stationary? Fixed. What is mobile? Is moving. So the stationary phase, usually we can take silica gel or alumina. Alumina is nothing but aluminium oxide. Aluminium oxide. Even you can take cellulose as a stationary phase. Cellulose also you can take it as a stationary phase. Mobile phase is usually the solvent. Solvent which can easily rise or which can flow easily through the stationary phase, which can easily move through the stationary phase, is nothing but a mobile phase, and commonly used one is solvent. Even you can take mixture of solvents also. So ಈಗ for example running race ಅಲ್ಲಿ starting point ಅಲ್ಲಿ ನಿಂತಿರ್ತಾರೆ. ಸೊ ಗೇಮ್ ಸ್ಟಾರ್ಟ್ ಆಗೋ ಮೊದಲು ಹೇಗಿರುತ್ತೆ, ಎಲ್ಲ ಕಾಂಪೋನೆಂಟ್ಸು ಇಲ್ಲಿರ್ತಾರೆ, ಎಲ್ಲ ಅಥ್ಲೆಟ್ಸು ಇಲ್ಲಿರ್ತಾರೆ. ಸೊ ರನ್ನಿಂಗ್ ಸ್ಟಾರ್ಟ್ ಆಗೋ ಮೊದಲು. ಸೊ ಒಂದ್ಸಲ ವಿಸಿಲ್ ಹೊಡೆದ ಮೇಲೆ ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗ್ತಾರೆ ಇವರು, ಕರೆಕ್ಟಾ? ಸೊ ಆಫ್ಟರ್ 2 minutes ಒಬ್ರು ಇಲ್ಲಿರ್ತಾರೆ, ಒಬ್ರು ಇಲ್ಲಿರ್ತಾರೆ, ಒಬ್ರು ಇಲ್ಲಿರ್ತಾರೆ, ಒಬ್ರು ಇಲ್ಲಿರ್ತಾರೆ. ದಟ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದೇರ್ ಸ್ಟ್ರೆಂತ್. ಅವರ ಮೂಮೆಂಟ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. ಒಬ್ಬ ಪ್ಲೇಯರ್ ಇಲ್ಲಿರ್ಬೋದು, ಇನ್ನೊಬ್ರು ಇಲ್ಲಿ, ಇನ್ನೊಬ್ರು ಇಲ್ಲಿ, ಇನ್ನೊಬ್ರು ಇಲ್ಲಿ, ಇನ್ನೊಬ್ರು ಇಲ್ಲಿ. ಸೊ ದಿಸ್ ಇಸ್ ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದೇರ್ ಸ್ಟ್ರೆಂತ್. ಅವ್ರು ಯಾವ ಎಷ್ಟು ಫಾಸ್ಟ್ ಇದ್ದಾರೆ ರನ್ನಿಂಗಲ್ಲಿ ಅದರ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ, ಅವರ ಸ್ಪೀಡ್ ಮೇಲೆ ಡಿಪೆಂಡ್ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ಬೇಸ್ಡ್ ಆನ್ ದೇರ್ ಸ್ಪೀಡ್. ಸೊ ಒನ್ ಮೇ ಬಿ ಹಿಯರ್, ಒನ್ ಮೇ ಬಿ ಹಿಯರ್, ಒನ್ ಮೇ ಬಿ ಹಿಯರ್, ಒನ್ ಮೇ ಬಿ ಹಿಯರ್, ಒನ್ ಮೇ ಬಿ ಹಿಯರ್ ಆಫ್ಟರ್ ದ ಕಮೆನ್ಸ್ಮೆಂಟ್ ಆಫ್ ದ ಗೇಮ್, ಕರೆಕ್ಟ್? ಸೊ ಮೂವ್ಮೆಂಟ್ ಆಫ್ ದ players takes place depending on their speed, correct? Depending on their speed. So hagene illu kuda the components will move in a stationary phase under the influence of mobile phase. Mobile phase na influence mele components will move in a stationary phase, in a stationary phase. So then they get separated under the influence of this mobile phase. So ಇಲ್ಲಿ ಒಟ್ಟಿಗೆ ಇರ್ತಾರೆ, ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಸಪ್ರೇಟ್ ಆಗುತ್ತೆ. ಯಾಕೆ ಸಪ್ರೇಟ್ ಯಾಕೆ ಆಗಬೇಕು? ಗೇಮ್ ಸ್ಟಾರ್ಟ್ ಆಯಿತು. ಬಿಫೋರ್ ದ ಕಮೆನ್ಸ್ಮೆಂಟ್ ಆಫ್ ದ ಗೇಮ್ ಎಲ್ಲರೂ ಒಂದೇ ಕಡೆಗೆ ಇರ್ತಾರೆ, ಆಮೇಲೆ ಏನಾಗುತ್ತೆ, ಸಪ್ರೇಟ್ ಆಗ್ತಾ ಹೋಗ್ತಾರೆ. ಇಲ್ಲೂ ಅಷ್ಟೇ, ದ ಸ್ಟೇಷನರಿ ಫೇಸ್ ವಿಚ್ ಕಂಟೈನಿಂಗ್, see here, this is the stationary phase in which we have a mixture to be separated, and this is the stationary phase. When mobile phase is passed through this stationary phase, it separates the components present in a mixture in this way. So the mixture alliro components alla separate agutte under the influence of this mobile phase, and this separation is based on the movement of individual components in a stationary phase under the influence of ಮೊಬೈಲ್ ಫೇಸ್. ಆ ಮೊಬೈಲ್ ಫೇಸ್ ಇಂಟರಾಕ್ಟ್ ಆಗ್ತಿದ್ದಾಗೆ ಆ ಕಂಪೋನೆಂಟ್ಸು ಡಿಫರೆಂಟ್ ಪ್ಲೇಸಸಲ್ಲಿ ಏನಾಗುತ್ತೆ, ಮೂವ್ ಆಗುತ್ತೆ ಆ್ಯಂಡ್ ಇಲ್ಲಿ ರಿಟೈನ್ ಆಗುತ್ತೆ. ಸೊ ಸ್ಟೇಷನರಿ ಫೇಸಲ್ಲಿ ದಿಸ್ ಕಾಂಪೋನೆಂಟ್ ಈಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಮಿಕ್ಸರ್, ದೀಸ್ ಆರ್ ದ ಕಾಂಪೋನೆಂಟ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ಎ ಮಿಕ್ಸರ್, ಬಟ್ ದಿಸ್ ಕಾಂಪೋನೆಂಟ್ ಈಸ್ ಗೆಟ್ ರಿಟೈನ್ ಆನ್ ಎ ಸ್ಟೇಷನರಿ ಫೇಸ್ ಹಿಯರ್, but this component retain on the stationary phase here. Why it retains here and why retains here? Because it is based on what is that property called adsorptive capacity of individual components. So depending on the adsorptive capacity of individual component, the retention of these individual components takes place on the stationary phase under the influence of mobile phase. So depending on adsorptive capacity. What do you mean by adsorptive capacity? So depending on the adsorption capacity. What do you mean by adsorption? Very simple. So this is a solid phase. So this is solid phase, and here is a liquid, and this is solid and here is a liquid. So this liquid molecules, the molecules present in liquid gets accumulate on the solid. So when solid interacts with this liquid, the liquid molecules get accumulate or they retain on the surface of a solid. This is the surface of a solid. These liquid molecules retain or accumulate on the surface of a solid. Then this is called adsorbent. Adsorbent. The surface of a solid which is provided for the adsorption of liquid molecules. This solid provides its surface for the accumulation or for the retention of liquid molecules. Then the solid is called adsorbent. The liquid molecules get accumulate on the surface of a solid, and this is called adsorbate. Adsorbate. And this phenomenon is called adsorption. Adsorption. So this phenomenon is called adsorption. ಯಾವುದಕ್ಕೆ accumulation capacity ಅಥವಾ adsorption capacity ಅಥವಾ retention capacity, solid ಮೇಲೆ ರಿಟೈನ್ ಆಗೋ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಇರುತ್ತೆ, ಅದು ಬೇಗ ಏನಾಗುತ್ತೆ ಅಕ್ಯುಮುಲೇಟ್ ಆಗುತ್ತೆ. ಸೊ ಯಾವ ಕಾಂಪೋನೆಂಟಿಗೆ ಅಕ್ಯುಮುಲೇಷನ್ ಅಂದರೆ ರಿಟೆನ್ಷನ್ ಕೆಪಾಸಿಟಿ ಕಮ್ಮಿ ಇರುತ್ತೆ, ಅದು ಸ್ಲೋ ಆಗಿ ಏನಾಗುತ್ತೆ ಅಕ್ಯುಮುಲೇಟ್ ಆಗುತ್ತೆ. ಅಂದರೆ ಸ್ಟೇಷನರಿ ಫೇಸ್ ಇವಾಗ ಏನಾಗುತ್ತೆ ಇಲ್ಲಿ, ಸೊ ಲೈಕ್ ದಿಸ್ we can take stationary phase. Stationary phase, let it be silica gel, it acts as an adsorbent. It acts as an adsorbent. Okay, and a mixture which containing different components acts as an adsorbate. Under the influence of mobile phase, they get separated on the stationary phase. They go on retaining on the stationary phase. First E component accumulate ಆಗುತ್ತೆ, ಆಮೇಲೆ E component accumulate ಆಗುತ್ತೆ, ಆಮೇಲೆ E component accumulate ಆಗುತ್ತೆ. And what it indicates, ಇದು starting point ಆದರೆ ಇಲ್ಲೊಂದು component accumulate, ಇಲ್ಲೊಂದು component accumulate, ಇಲ್ಲೊಂದು component retain ಆಗುತ್ತೆ ಅಂದರೆ the reason here is adsorption capacity of this component is more compared to this. And this get adsorbed on the adsorbent slowly because its retention capacity is very less, its retention capacity is more. And ಇಲ್ಲಿಂದ ಸ್ಟಾರ್ಟ್ ಆದರೆ ಕಾಂಪೊನೆಂಟ್ಸ್ ಜಾಸ್ತಿ ಮೂವ್ ಆಗಿರೋದು ಯಾವ ಕಾಂಪೊನೆಂಟ್, ಈ ಕಾಂಪೊನೆಂಟ್ ಜಾಸ್ತಿ ಮೂವ್ ಆಗಿದೆ and ಈ ಕಾಂಪೊನೆಂಟ್ ಕಮ್ಮಿ ಮೂವ್ ಆಗಿದೆ, which means to say the distance traveled by this component is less and the distance traveled by this component is more, and that shows the difference in the adsorption capacity of different components present in a mixture. So the principle behind chromatography is adsorptive capacity of different components present in a mixture. Some components are having high adsorptive capacity and some components are having low adsorptive capacity. On the basis of this, the component which is having high adsorptive capacity retains earlier on the solid phase, that is on the adsorbent. The component which is having low adsorptive capacity retains on the surface very slowly or later. So this is the phenomenon is called adsorption. And remember, adsorption phenomenon is a surface phenomenon. It takes place on the surface of a solid and it can accumulate either the liquid molecules or the gaseous molecules. Gaseous molecules solid surface ಮೇಲೆ accumulate ಆಗಬಹುದು ಅಥವಾ liquid molecules ಅಥವಾ gaseous molecules ಇವೆರಡು molecules solid surface ಮೇಲೆ accumulate ಆಗಬಹುದು. accumulate, retention. So ಯಾವ surface provide ಮಾಡ್ತಿದೆ ಇಲ್ಲಿ, solid provide ಮಾಡ್ತಿರೋದ್ರಿಂದ ಅದನ್ನು adsorbent ಅಂತ ಕರಿತೀವಿ. ಸೊ ಯಾವ ಮಾಲಿಕ್ಯೂಲ್ಸ್ ಅಕ್ಯುಮುಲೇಟ್ ಆಗ್ತಿದೆ ಅದನ್ನು ಅಡ್ಸಾರ್ಬೇಟ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ಕ್ರೊಮೆಟೋಗ್ರಫಿಲಿ ಸ್ಟೇಷನರಿ ಫೇಸ್ ಅನ್ನು ಅಡ್ಸಾರ್ಬೆಂಟ್ ಅಂತ ಕರಿತೀವಿ. ಆ ಕಂಪೋನೆಂಟ್ಸ್ ಪ್ರೆಸೆಂಟ್ ಇನ್ ದ ಮಿಕ್ಸ್ಚರ್ನ ನಾವೇನು ಕರಿತೀವಿ, ಅಡ್ಸಾರ್ಬೇಟ್ ಅಂತ ಕರಿತೀವಿ. ಡಿಪೆಂಡಿಂಗ್ ಆನ್ ದ ಕೆಪಾಸಿಟಿ of adsorption, the different components get retained on the different places on the stationary phase. So the principle behind chromatography is the differential movement of individual components through a stationary phase under the influence of mobile phase, under the influence of mobile phase. And movement of, ಇದು ಸ್ಲೋ ಆಗಿ ಮೂವ್ ಆಗ್ತಿದೆ, ಇದು ಫಾಸ್ಟ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದರೆ ಏನರ್ಥ? ಸ್ಲೋ ಆಗಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂತ ಹೇಳಿದ್ರೆ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಕೆಪಾಸಿಟಿ ಜಾಸ್ತಿ ಇದೆ, ಫಾಸ್ಟ್ ಆಗಿ ಮೂವ್ ಆಗ್ತಿದೆ ಅಂದರೆ ಏನರ್ಥ? ಸೊ ಅದರ ಅಬ್ಸಾರ್ಪ್ಷನ್ ಕೆಪಾಸಿಟಿ ಕಮ್ಮಿ ಇದೆ. ಇಟ್ ಈಸ್ ನಾಟ್ ರೆಡಿ ಟು ರಿಟೈನ್ ಆನ್ ದ ಸ್ಟೇಷನರಿ ಫೇಸ್ ಅರ್ಲಿಯರ್. ಓಕೆ, ಸೊ ಅಲ್ಲಿ ಡಿಸ್ಟೆನ್ಸ್ ಟ್ರಾವೆಲ್ಡ್ ಬೈ ದಿಸ್ ಕಾಂಪೊನೆಂಟ್ ಈಸ್ more and this is less. So this is nothing but the principle behind chromatography. So there are two types of chromatographic technique. So one is adsorption chromatography, second one is partition chromatography. Adsorption chromatography, adsorption chromatography, and second one partition chromatography. So adsorption chromatography and partition chromatography, there are two types here. In adsorption chromatography, again we have two types. First one is column chromatography, second one is thin layer chromatography, and in partition chromatography is also called paper chromatography. So let us consider the types of chromatography in the next class. Thank you.